Hello, my name is Caden Taylor. I am a senior undergraduate studying fire ecology and management at the University of Idaho. I am doing my final project on the Brundage Bear Basin area. I will be analyzing the vegetation composition of the site from two time periods to see how anthropogenic factors as well as weather patterns have altered or modified the changes to the vegetation. In this presentation, I will be covering the background information on the Brundage Bear Basin area, the history of the land, how the Forest Service has utilized the land, and what changes are being made to the land. I will then go over the management objectives as well as the methods used for this study. I will then discuss the results of my findings and what the best ways to proceed with the land use would be in order to restore and protect this land to provide as a habitat. The Brundage Bear Basin area is located just north of McCall and is home to many native species of wildlife and vegetation. The dominating species of trees in the area are ponderosa pine and Douglas fir forests, as well as subalpine fir and lodgepole pines scattered throughout. It is also home to mountain lions, elk, whitetails, mule deers, and black bears. The proposed project area covers 1,400 acres of forest vegetation treatments, including thinning, prescribed burning, and tree planting. The management history in the area includes the maintenance of trails and roadways, as well as creating a trail system throughout the area that leads to McCall. There are also a few timber operations that are performed throughout. I will be examining the changes of vegetation between 2001 and 2016 to understand how the habitats for species have been affected, as well as what anthropogenic factors have led to the decline in these habitats. I will be examining the same landscape over two time periods to understand how these changes have affected the biodiversity of vegetation type and what weather patterns have caused these changes to occur. I will also explore weather patterns over the same two time periods and examine how the changes in weather have played a role in vegetation variability. Weather patterns will be measured using weather station data for the nearest station, and I will examine any changes in historical weather variation over a time period of 10 years. I will also quantify these changes and discuss what impact these changes mean and what they can mean for the future of the area. For the methods, I began by acquiring numerous layers from the Landfire website. I selected the existing vegetation type and cover type layers between 2001 and 2016. I did this in order to compare for a comparison of what changes have been made to the composition of the site. I also downloaded weather data acquired by the Ski Hill RAWS station located just northeast of the project site and compared the changes in weather patterns that have occurred over the time period. I then imported the weather station data into Fire Family Plus to analyze the weather patterns from 2006 to 2016. This is helpful in understanding how weather patterns have affected the vegetative composition. In order to analyze the history of the existing vegetation types for the project site, I downloaded the Landfire data from 2001 and 2016, then imported the data layers into ArcGIS and created bar charts based on the data provided. In order to collect weather data and analyze changes in weather, I downloaded the RAWS weather station for the Ski Hill station from the Forest Service Wildland Fire Assessment website. I then imported the data into Fire Family Plus and created graphs for mean temperatures and precipitations to compare the site's weather patterns from 2006 to 2016. The changes in annual mean temperature and annual mean precipitation are used to further understand how the weather has affected the vegetative composition as well as management practices performed on the site. The first comparison is existing vegetation types for the project site. The picture on the left shows the existing vegetation type for 2001, while the chart on the right represents 2016. The most notable changes are displayed in a reduction in closed tree canopy, but there is an increase in open tree canopy. Many species that affect the vegetative composition throughout the habitat and grazing will prefer more closed tree canopy cover and have been driven out of some areas in the Bear Basin due to this reduction. Due to management practices such as thinning, recreational development, and logging, there are reductions in vegetation density as the closed tree canopy has been replaced with more growth of shrubland vegetation types. The two graphs above represent the changes in canopy cover from 2001 and 2016. The graph on the left represents 2001. The values below are the proportion of the forest floor covered by the vertical projection of tree crowns. Notable changes are the drastic decrease in canopy cover that covers 2% of the forest floor from 2001 to 2016. This can be attributed to the maturation of juvenile trees, as well as the changes in stand growth. There are also increases of canopy cover from 35 to around 50%. Which is caused by further stand growth as well as maintenance of trails. This can also be accredited to practices of thinning and logging throughout the area. These two graphs represent the amount of precipitation as well as the mean temperature the site has experienced from 2006 to 2016. The increase in mean temperatures over the years has led to drier fuels as well as more aridity. This is a leading cause in management practices performed by the Forest Service in the area, such as thinning and logging. These practices are used to reduce the frequency and severity of wildfires that may occur in the area, as well as projects for establishing more recreational activities, such as mountain biking and trails for the community to use. Changes to global meteorological patterns, such as increases in temperature and decreases in precipitation, can be accredited to anthropogenic factors, such as climate change and global warming. Increases in global emissions in recent years are the largest reasons why these changes are occurring. The changes seen in the Brundage Bear Basin area have been contingent with appealing to tourists and recreation, rather than focusing on full habitat and ecological restoration of the area. Changes in the existing vegetation type have been a disservice to not only wildlife, but also vegetative composition and biodiversity in the area, and have been driven out in many cases. This can be detrimental to not only the community of McCall, which is located just south of the site, but also for the ecosystem. Wildlife can play a large role in maintaining an ecosystem's health by managing the browsing wildlife population. Such changes to wildlife population can lead to overgrazing or undergrazing, as well as an abundance of wildlife species that imbalance the natural chain of order that occurs here. Not only this, but it also maintains the species diversity and plant community. The changes in canopy cover have had the same effect as existing vegetation type. There are benefits to these changes in the area as well. Increases in recreational uses, such as trail management and construction of infrastructure, has reduced the frequency and severity of wildfires in the area and has provided as fire breaks. In recent years, anthropogenic factors have led to changes in weather patterns, such as the increase in annual mean temp and reduction in annual precipitation. These changes in weather have led to the drying of fuels, which makes the area more volatile if wildfire were to occur here. Though further development of the site for recreational purposes seems to be the demise, there are management practices that can be performed to restore much of the forested area to a more habitable site for wildlife and vegetation. The planting of native species and reintroduction of removed trees may be a long process before it can be beneficial, but it is necessary to restore the historical vegetation types and cover types, such as an increase in canopy cover. Maintaining the understory and litter is also an effective way to reduce the chances of wildfire severity and frequency. Cooperation between the public as well as land managers can serve a great deal of benefit to the site. Reducing the focus on appealing to tourism and aiming more towards restoring the site to its natural state can be a stepping stone to restoration. If you have any questions on what was presented, feel free to reach out to me by email. Thank you for listening.